Hey everyone, Chang here and welcome to my channel. For today's video, I'm going to go over something that I find quite enjoyable. I'm talking about combinations. Combination especially with individual factor or factors that are independent, right? So what do I mean by that? Well, first and foremost, combinations, the lovely thing about combination is that basically those problems are fairly simple. They ask you with all these different possibilities, how many are there total? Now, some of them are a little more complicated, give you sort of, I guess you could say, conditions or leeway, right? If something occurs, then this other combination might not be able to happen. And that makes problems a little more complicated. But the most basic and the fundamental that you would normally encounter in the statistics, in a math competition, or even in SAT, ACT, standardized test kind of questions, are the ones that are independent. Meaning that whatever happens the first time doesn't affect what happens the second, the third, the fourth, or so on and so forth. Now, here's a classic example of independent, I guess you could say, situation. Here we have one coin. When you flip a coin, there's only two possibilities. There could either be heads or tails. Okay? Now, if you flip two coins, right? Doesn't matter what the outcome of the first coin is. The second coin is basically, could potentially be head or tail. So in this case, two coins, you can have both of them are head, right? Then you can have a head or tail or head. And now here's the thing that can trip up a lot of people. Right? Head and tail and head are two different things because we're talking about two different coins. We can say this is coin 1 and coin 2. Head for coin 1 and tail for coin 2 is very different from tail for coin 1 and head from coin 2. Right? And then we also have the possibility of tail. Right? So that's what happens when you have two coins. Right? So this is one coin. This is two coins. And then here's one thing I really want you guys to see. Yes, eventually, you're not going to go through all this, right? You're going to figure out a way, and I'm going to go over a way that can easily come up with all the possible combination. But in situations where you have to write it all out, because guess what? There's going to be situations, especially complex situations, where sometimes it's just a lot easier to write out all the different possible combination and then count them instead of trying to make some complicated, crazy formula math, right? So here's the thing. That's two coins, three coins. Try to stay organized as much as possible. In this case, I'm going to start off, of course, with all heads. Right? And this is talking about three coins right here. And then I'm going to slowly change one at a time. I'm not just going to go at random because then if I'm not organized, I'm going to accidentally overcount or undercount, missing one combination that should exist or putting the same combination twice. So in this case, well, let's just do this. Let's keep this as head, let's keep this as head, and let's just make this tails. Alright, well, let's do the next one. Heads, let's make this tails, but then change this back to head. And then same here. Let's do this one tails, and then we have head. Okay, cool. So these are all situations with only one tail. Alright, well, let's just change it up again. Let's do heads, and then now we have two tails. Okay, we can also have the possibility of tail, head, tail, or tail, heads, right? And that's it. That's all the possibility of two tails. And then the last one, of course, is all tails. Right? So you try to be as organized as possible. All heads, then situation where there's like one tail, and then situation where there's two tail, and then situation where all three. So that we can figure it out. There's 2, 4, 6, 8. All right, cool. And then we can keep on going. Now, before we keep on going, because as we go more and more, it's going to drive us up the wall. Let's notice something. For one coin, there's two possibilities. There's a head and a tail. So technically, there's two. Now I'm going to write it in this interesting way. 2 to the first power. Okay, because there's only one coin. Now, let's look at this one. There's two coins, right? And because there are two coins, now there's a possibility, even if coin 1 is head, right? There's two options. And if coin 1 is tail, there's another two options. So technically, we have, for the first coin, there's two options. And the second coin, there's also two options. And since each and every one of these options have another two options, you multiply them. 2 times 2 in this case is 4, or 2 squared. Cool. Let's keep looking. All right, 3. You guys can sort of guess, but if not, that's fine. Once again, you have your first option, your first coin, two options. And out of every one of those first coin two options, right, there's another coin that gives you another two option. And out of every one of those, there's another coin that gives you 2 options. So in this case, that's going to be what? 2 times 2 times 2, or 2 to the third. Okay, so in this case, 2 to the first, 2 to the second, 2 to the third. And then, well, 2 to the third is 8, hence you can count, right? 1, 2, 3, 4, 5, 6, 7, 8, 8 options. So without continuing on just writing out all the possibility, we can see, as we go, for example, 8 coin, we can already guess. Each and every one of those coins is going to present another 2 options. So the combination of all the possibility of 8 coin flip is going to be 2 times itself 8 times. So it's going to be 2 to the 8th power. Now, there's a reason I wanted to show this. This basically allows you to see intuitively what the potential formula is. You look at every situation, every aspect, and then you figure out all possibility. First coin, 2 possibility. Second coin, 2 possibility. Hence, I can multiply. If, for example, it is not this second coin with 2 possibilities. Let's just say a coin and a dice, which is also very common that they love using. Coin and a dice. A standard dice, 6 side. Coin, 2. So if you want to find the combination of a coin and a dice, well, guess what? It's going to be 2 for the coin and 6 for the dice. And then you would just end up multiplying. For every possibility of a coin, there's 6 potential rows. And you can think of it vice versa. For every potential row, there's a possibility of 2 coin results, right? Head or tail. So then you're going to have 2 times 6 or 6 times 2 and so on and so forth. So let's look at different problems with different potential combinations just so you guys can get the idea. But here's the key. All it is that every time you have more than one factor, it multiplies it, right? It gives you an exponential amount of possibility, right? 2 and then another potential 2 which makes you multiply, and another potential 2 makes you multiply. Now these different ones are not always going to be 2, so pay careful attention to the actual situation in the problem, how many possibilities there are, and then the multiplication that's occurring. Alright, so right here we have a standard word problem which requires us to find combinations. Now, just a heads up, these are called combinatorics in case you guys are curious about the title or want to look up more problems. Why not, right? So, in a deli shop, you have the choice of white or whole wheat bread, cheddar or Swiss cheese, and 5 types of meat. How many possible combinations are there? Now, this is a complicated problem because each and every one of those aspects has different amount of choices. But when we break it down, it's fairly simple. First, let's just look at the bread. There's 2 choices, right? We have white and whole wheat. So no matter what, we're going to have 2 possible combinations. Everything that's going to use white and everything that's going to use whole wheat. So these are the bread, right? Okay. Now, we also have the type of cheese. We have cheddar or Swiss. So in this case, another 2 combination. Every time you are working with different bread, you also have the possibility of it potentially being with cheddar or Swiss and all the different combinations of that. So we have 2, and this is going to be cheese. And then afterwards, we have the type of meat. There's mentioned 5 types of meat. So now we have something drastically different. Rather than 2 like we're accustomed to here, in terms of meat, we have 5. So M-E. All right, cool. So when we look at this, the possibility, we can choose whichever type of bread, 2 possibility. For every 2 possibility, we can choose 2 types of cheese. For every 2 types of bread with the 2 types of cheese, we can actually choose 5 different types of meat. So in this case, we're actually going to have to multiply them all. Now, just for kicks, just to let you guys know, the formula that they would say is like M and N, where M and N are independent factors and so on and so forth, which I mean is great, I guess, if you really just need to write a formula. But writing something like this is not, I don't think it's particularly helpful, especially look, this is just a situation with 3. This formula sort of implies that there's only going to be 2, which is never really the case, right? No one's going to make it that easy. So in this case, 2 times 2 times 5. Well, in this case, 4 times 5 is 20. So there's actually 20 possible combinations. And remember, if you're not sure, if you have extra time, right, and you can't recall if this is the formula and you want to double check, you can write out all the combinations, right? Just make sure you're organized. The first one, write out all the possibility with wheat or whole wheat and or with white, right? Just pick one and then be organized about it. All of white, and then this is all the possible combination, and all of whole wheat, and this is all the possible combination. And hopefully by then you'll have 20 combinations to verify your answer, or begs you to double check a little more. Now, for this next problem, it's not difficult by any standards, but I did like the wording of it. I feel like it's something that you guys have to at least see once, because for some reason, they love writing a problem like this. So, how many possible outcomes are there if you roll 3 standard fair dice? Now, especially when you're talking about dice, this usually occur, and that's why I want you guys to see it. The standard fair dice, like terminology. Standard is automatically assumed that it's gonna be 6-sided. Right? I don't know who decided that, but basically all, Dungeon and Dragon, all you guys are not going to be all that happy, but standard 6-sided. It'll save you a lot of headaches, right? The other thing is fair dice. Eventually, you're going to encounter problems where it either doesn't say fair dice, or it's going to go out of its way to say that it is not fair. Now, here's the thing. Every time we roll a dice, a 6-sided dice, we assume that the basic possibility of each and every one of the sides showing up is equal. If it's not fair, if it's loaded, that's another word they would use, if it's loaded in any way, the probability changes drastically, the possible combination might change as well. So be very careful of that. This one, luckily, not so much, right? This is a fairly standard, easy problem. How many possible outcomes are there if you roll 3 standard fair dice? So keep in mind that the outcome of one dice, right, doesn't affect the outcome of the other. That's why they're quote unquote independent. If they're dependent, that means the outcome of one will affect the other. Well, dice, one doesn't affect the other. Maybe if you one hit the other, but that's nitpicking. But normally, doesn't matter. You can roll one at a time. So in this case, possibility of the first dice, 6 different face. Standard 6. The possibility of the second dice, 6 different face. All right. Possibility of the third dice, 6 different face, right? And no, this is not the devil's number, just dice. All right, so 6, 6, 6, right? In that case, you just multiply the 6 together, 6 cubed, and then you would find the entire combination, and that's all it is, right? So, easy problem. Careful of the wording. The wording tells a lot, right? And this is a standard wording for any word problem that requires you to talk about dice. Right here is one that can fall under the category, I want to say, sort of a trick problem. One needs to be very careful with this because based on the understanding and the wording of the problem, it's so easy to make a mistake. So this is not difficult in any way, but I just want to point this out. So how many 5 digits whole number can you basically have? Uses zeros and ones, right? So in this case, here's the thing. 5-digit whole number is easy, right? All we have to do is look at 5 number, and in this case we're just talking about 0 and 1s, right? It's not talking about the standard 0 to 9 kind of thing. All right, so there's going to be 5 numbers right next to each other. That makes it 5 digits. Now here's the key though. Here's the one where a lot of people can potentially make a mistake. The first digit, there's actually only one possibility, right? 1. You can't put 0. Because by definition, we're talking about a 5-digit whole number. If this happened to be 0, right, we don't say, for example, this is not a 2-digit number, right? It's just 1, right? Because guess what? That's still 1. We wouldn't say this is a 3-digit number. Same thing, right? This has to be 1. If it's a 0, this whole thing becomes a 4-digit number. Doesn't matter what these guys are. But immediately, if this is 0, then this is a 4-digit number. So we have to be very careful. Isolate this one as 1 because that's the only possibility for a 5-digit number. Then everything else is just 0 and 1, right? So if we look at this, only one possibility for the first one, but everything else are 2 possibilities each. So I'm just going to put that to clarify that's not a 5-digit number. We're just multiplying. In this case, 1, it has to be 1. Then afterwards, you have the possibility of it being 0 or 1. So you have 1 times 2 times 2 times 2 times 2, which is what? 16? And just like that, there's 16 possibility of 5-digit whole numbers that uses only zeros and 1. So once again, every time you encounter a problem, be very careful. Understand the problem. This one right here is particularly tricky. That's why I liked it, and that's why I decided to show you guys it. But if you're careful about it, making sure you truly understand what possible combination there are, and there aren't, you should be just fine. All right, so hopefully with that, we just had a little fun, work with basically combinations, counting combinations that have independent factors. Now remember, there are going to be more complicated ones as we move on, right? There's the one that are dependent on each other. Like for example, this one, it's sort of dependent. If the first one is 0, then it doesn't really count, right? But luckily for us, it doesn't matter at that point whether it's 0 or 1. Eventually, it gets more complicated that every time you have one possibility, one combination, the other ones are all moot. So we have to be careful of that. But once again, this video was supposed to be just lighthearted, have a little fun, right? Learn a little bit about combinations. If you haven't encountered them already, watch out for potential pitfall, and then enjoy. Thank you for watching this video. See you in the next one.